you ever wanted to explore another planet, to uncover its history, to discover something new? Toastmasters and guests, if you've ever wanted to do this, you might be interested in exogeology. I've been running a website about exogeology for over 2 years called Exogeology ROCKS. Wait, exo what? Can you say that again more slowly? Exogeology, also called planetary science or planetary geology, is the geology of other planets. Being an exogeologist means you get to discover how other worlds work, including how they formed, what they're made of, and what's happening to them right now. Exogeology is a combination of 2 different sciences, geology and astronomy. What is geology? Geology is the study of Earth. It includes subjects like rocks and minerals, volcanoes, plate tectonics, rock layers, fossils, caves, erosion, and many other formations and processes that shape the Earth. What is astronomy? Astronomy is the study of space. It includes subjects like stars, planets, galaxies, black holes, space travel, and everything else out in the universe. As an exogeologist, you get to combine these 2 sciences and study the geology of other planets, and moons, and asteroids, and comets. But you don't have to go out into space yourself and risk your life to look at rocks. Instead, you send robots out into space. These robots will either orbit the planet that you want to study, land on it and stay in one spot, or land on it and drive around to different places on the surface. These robots will take along with them cameras and other special equipment. Using machines like this, you can look at formations such as volcanoes, sand dunes, and craters. You can take rock samples and analyze what they're made of. Most importantly, you can seek out anything unusual, abstruse, or mysterious. For example, Saturn's largest moon, Titan, is a very mysterious place with a haze of clouds. In 2005, the Huygens probe broke through that haze. First, it separated from the Cassini spacecraft it traveled with. Then it hurtled through the atmosphere of Titan, spinning around, snapping pictures, and taking measurements. Once it reached the surface of Titan, it gathered as much data as possible and sent it back to Earth. We now know that Titan has a thick, dense atmosphere, lakes of hydrocarbons, and possibly even volcanoes that erupt water. It's a good thing that we can send robots instead of people when we have no clue what we're going to find. Speaking of sending robots out to gather data, last November, NASA sent a robot out into space to rove the surface of a slightly well-known world compared to Titan, Mars. This Mars rover is officially titled the Mars Science Laboratory, or MSL, but its friendlier name is Curiosity. The team of people working with Curiosity will drive it around, take rock and air samples, and try to figure out whether or not an area on Mars was ever habitable for Martian life. No matter what the results are, I'm sure curious to find out. We won't have to wait very long either before this newest, biggest Mars rover gets to work. Curiosity is scheduled to land on Mars on August 5th this year. Another exciting aspect of exogeology is only beginning to surface. Not only are there other planets in our own solar system to explore, but there are other solar systems, each with their own set of planets. How do we find these exoplanets, as they're called? One way is to look at the light from a star. When a planet orbits around a star and blocks a portion of the star, gets in front of it, from our perspective, it blocks out a portion of the light. the star dims ever so slightly. A planet moving in front of a star from our perspective is called a transit, and you can see a transit even from our own solar system. Venus transited the sun just last month. When it did, it blocked out a portion of the sun and looked like a tiny little black dot. The sun dimmed just a tiny bit. When another star dims just right in a sequence, then it's a signal that there might be a planet orbiting that star. What might these exoplanets look like? How might they compare to planets in our own solar system? How do those planets in our solar system compare to the Earth? What you find on far-off worlds is important right here. Comparing the geology of other planets to our own planet helps give us insight into the way our own planet works. And it gives us an idea of what planets outside our solar system might be like. Searching for water and certain other materials on far-off worlds in the rocks and ice helps in the search for alien life. Investigating the history of other worlds and of the Earth gives us clues to how our solar system formed. As an exogeologist, you get to explore far-off worlds, uncover their history, and you never know what you'll discover next. Visit exogeologyrocks.com to find out more. Thank you.